Hi everybody. In this tutorial today we are going to extract words from a book. That means that we are going to do segmentation, an object segmentation. Basically we are going to do segmentation for the lines, and then for each of the lines we are going to do a words segmentation. So we are going to extract each word, and we are going to keep the order of the word, so we can show easily each word in the page. So first of all, let's take an image of words in a book. I will upload to my GitHub this image as well as the coding. So first of all, let's create a Python program, and in the first phase we are going to import OpenCV and basically show the image as is. So keep up this tutorial. We are going to do some cool things using this image. Okay, this is the path to the image, and we will use the imshow function of the CV2 Python library. Let's give the window a name. We call it show the words, and then our array and the image, and let's run it. Okay, nice. So we have the image, so we are ready to continue to the next step. So the next step is creating a function, and this function will get the image, our image, as an argument, and we are going to convert the image to grayscale. That means black and white, and then we will do some thresholding in order to focus only on the let's say the characters on the image. So as you see, first of all, we are converted to grayscale. Then we are going to do some threshold. The threshold would be over 170. Okay, let's see that everything is working. So we have to run the function. As you can see, it's like a freestyle coding, so hopefully I will not have any mistakes or bugs, but if yes, we will fix it during the coding. So let's show our image, our fresh image. Let's run it, show it along with our original image. We have a bug here. We have to change the argument. It should be color BGR to gray. Okay, now we are ready to run. As you can see, we have a problem. The text is in black, but we need to extract the text, so we need a black background, and all the characters should be in white. So basically we are going to change the argument for the threshold function to _env. Okay, now it's okay. All the text is white and the background is black. So let's continue to the next step. We use the Gaussian blur function. We need that the lines and the words will be more blurred. It will help us to extract it. Okay, now you can see that the image is more blurred, but yet it's not good enough, since we have we need that the words will be more, let's say, dense together. So let's do another threshold process. Okay, now the words are more consolidated one to each other, and we are ready to continue with the next step. Okay, let's write some comments. As I said earlier, the purpose of this step was to merge the words, to consolidate it one to each other. And now I think we are ready to continue to the next step. And the next step is basically doing a line segmentation. So as for now, we are going to leave the words aside, and we will do word segmentation in the next step. But as for now, let's do some line segmentation. That means that we would like to focus and extract each of the lines in our book page. So we will create an empty array. Each item in the array will be one line. And let's create a kernel of NP1s. So basically we have to add a numpy array to our Python. We are going to use this kernel for the rows. I will explain it later. So in order to merge all the words in one line, so we can extract all the words, we are going to use the delete function. It's an OpenCV function. We will send some arguments. First of all, our fresh image, the new kernel that we defined earlier, and we will use only one iteration. It should be good enough. Okay, let's run the return image. Let's show it. I have a syntax error. Okay. As you can see, the outcome, each line is separated as a white area, and now we are ready to use the contours function in order to extract any of these line areas. So let's find our contours. Let's call the return variable contour rows, and we will use the CV2 find contours. We will send several arguments. First of all, our image, our dilated image. We will use the copy function in order to copy our image and not to do any changes on the original one. We will use the external argument, since we are only looking for contours that are around objects and not inside objects. And let's for now draw all the detected contours. We will draw it on our original image. So let's see the outcome. Let's choose a green color and the thickness of the line, and let's run it. Very nice. As you can see, each line has a green segmentation around all the lines. So the next step is drawing our rectangle in around each of the lines. So we need to run a for loop inside our contours, and we will do a rectangle drawing around each of the located areas of these contours. So we are creating a for loop of a row inside our contour rows, and we are detecting the area of each of the detected contours. And if the area is above 500 pixels, that means that it's big enough, and we will extract the coordinates x, y, width and heights, and then we will put a rectangle using these coordinates. This is a straightforward of OpenCV Python library. So the arguments will be our original images, the points, the coordinates for the x and y for these rectangles, choosing a color, choosing a thickness, and I think we can run it. Okay, nice. So now each of the rows has a orange rectangle. So we can remark our draw contours, and now we can see only our rectangles. Each of the rows has a rectangle. So next we would like to create our lines array, and we will append or insert each time that we are detecting a contour around the line, and let's print the length of our array. So basically we have 33 lines. Okay, let's continue to the next step. We would like to sort the lines that, since the detection process has its own priority, we would like that all the lines will be sorted from the upper line to the lower line. So how can we achieve that? We are going to create a lambda function, and we are going to send our y coordinate, which is line of 1. That means that the sort will be using the y-axis. So now this sorted line array is basically all the lines sorted from the upper line to the lower line. So now let's create our word segmentation. That means for each of the lines we will extract all the words, and we will use a similar process that is based on the CV2 contours. First of all, let's create another kernel. We will call it kernel words. Now let's create another dilate process using the CV2 dilate function. We will use our original image before we change it or twist it to our lines. Our let's call it the gray, black and white image. And once again, let's show our image using this word dilation. So as you can see, each of the words is consolidated, and now it will help us to use the CV2 find contour function. Okay, now for each of the lines, I remind you that each line is sorted from the upper one to the lower one. And now for each of the lines, we will look for the region of interest. What does it mean? We will extract the x, y, width and height. And now from each of the lines, we are going to extract from our dilate words image the specific line using this command. Basically, we are getting from the full image only an extracted image of this specific line inside our loop. And now, just to double check that we are seeing a rectangle around each of the lines, we would like to draw a rectangle, a green rectangle around each of the lines. Basically similar as we did earlier with the find contours. So we have a green line around each of the lines. So just to double check that the second rectangle is working, let's do a mark inside for our previous line. As you can see, it's working fine. So basically we have a detected line inside our loop. So we don't need this rectangle, it's just a debugging process. We need to find contours for each of the lines. So once again, let's use the find contour function, and we will send our region of interest, only the specific line, and let's extract or find contours only in external ones. So basically we will get each of the word inside our line. So let's loop inside the outcome, this contour words. Let's get the coordinate of each of the words, and let's create a rectangle around each of the words. So in the previous process we draw a rectangle around each of the lines, and now we would like to draw a rectangle around each of the words. Please notice that x1, y1, w1 and h1 is a coordinate for each of the detected words. So in order to draw a rectangle around each of the words, we are adding for the original x the x1, and for the original y the y1, and the same with the width and the height. So let's run it, and now we can see that each of the words has its own rectangle. That means that each of the words is being detected and segmented. Nice, very nice. Now the words are sorted randomly, so the detection process has its own priority. So in order to sort the words from left to right, we need to create our words array and send our coordinates. That means the x, y, width and the height, and we will send our full coordinate. That means x plus xy is the original position of each of the words. So now we are heading to our sorting process. So let's call this array sorted words, and now we'll do the same as our lines, but as for now the argument for the sort will be the 0 position. Okay, x is the 0, y is number 1, width is the 3rd position, and height is the 4th position. And now, since we would like to sort by the x, it's the 0 position. Okay, and the last phase is creating a full array, and this full array will has basically two major arguments. One is the line number, and the second one is the coordinate of each of the words. So we are running a loop inside all of our sorted words, and we are creating this all array. Let's print the outcome. Okay, as you can see, for each of the words we have the line number and the coordinates. This is another word and this is another word. You can see, for example, this is line number 9 and the coordinates of the word. Very nice. So these are all the words in line number 9. So now we are ready to demonstrate all this process. As for example, let's show only the first word in our page. So how can we achieve that? We will use our final array, this all array, and let's extract the word in position 1, and from this word let's extract the position 1, which is the coordinates. I remind you, position 0 is the line number and position 1 is coordinates. So now let's draw our image. So we will create a new image and we will get position 1 and position 3. Position 1 is the 137 and position 3 is 166, and doing the same with the width and the height. And let's show this ROI word. It will be another new image, and let's run it. As you can see, this is the word book. You can see on the left. Let's move the windows. Okay. So you can see this is the word book. Okay, it's a word in position 1. Position 0 is the letter A, so position 1 is the word book. Let's try another one. Let's take word number 2. So now we're getting the word off. Okay, position 0 is A, position 1 is book, position 2 is off. Let's get another word. Well, where is it? Here it is, the word myth. Hope you enjoyed this tutorial. Thank you very much. Hope to see you soon. Bye bye.